How are we looking? Everything's looking good. Okay. All right. Everything's looking good. What's up, Zero G Brent? We are back to cast more propellant. Oh, let's check this out. Let's clean up everything. Do a quick cleanup before we start back. That red iron oxide. As you can see, that red iron oxide got right here. It stains everything. It's got a little bit of a stain. All right. Propellant is 80 degrees. Yeah, you are the ad. I added you as admin. We need some moderators, so I'm adding some people as moderators just in case, say, some spammers come in or someone comes in. All right. Hmm. What? Okay. All right. So we're gonna do a second pour of propellant. First pour went great, as we could see so far. Um, Not 100% sure yet because the finical section isn't busted out yet to see if there's any air bubbles, but it went like every other time, and every other time went great. So if you're just tuning in, please like the stream. That'd be great. And we're gonna get started in a few seconds. Once I get situated. All right, let's get this stuff. Let's turn the stove on low. Actually, yeah, that's okay. We could keep that on low. Okay, so now we'll wait a few seconds for everyone to get in so nobody misses out on any parts. All right. I think I mitigated the issue with the video dropping out. Watch it drop out now, but I think I mitigated the risk. Everything's looking good. I'm going to take a few videos while we wait for some people to join. Let me get the chat pulled up so I can see all the live chat. Okay. All right. I'll pull up this top a little bit. I think I'm going to need to go on autofocus on this one. Manual focus. Let's go. That looks pretty good. All right. I'm going to get a quick video of what the felt looks like inside the tube. All right. There's some propellant. I would see it dropped out. I didn't. Okay. I don't know that dropout issue. I'm gonna look into that further one later today. So if I live stream in the future, just clean off. Okay. Okay. It's live now. Just clean off this silicone rod with some water because some of the propellant fell on it, and then it's tough to get this top plate off. The propellant is water soluble, so that really helps out. It can dissolve some water. That helps out, but then also it's tough when okay, so all right. Yeah, so we're gonna take off the top plate. I can show you guys how it's gonna look. How it looks so far. You see the first pour, and we're gonna add another segment on top for this next test, for this next pour. Here, I just use painter's tape, works great. Now I do secure on the outside, but then I do one more thing I'll show you guys in a moment. Now this secures the outer rim. I do put a few pieces of tape inside. Why is this glitching out so much? Okay. Okay. So yeah, I really do. I gotta get some better live streaming hardware. Not working great right now. What I got. Okay. Now I'm gonna grab a few. Where's the live chat? Okay, so I'm gonna grab a few small pieces of this tape. I do 3. I'm gonna grab this end, pointy end. I grab it on the end like that. This will just secure it in the inside. So we're gonna go down like that, push it out, secure it inside like that. It's tough to see for you guys, but that's how I do it. Just to make sure there's some tape in the inside. We got some bonding in the inside with the tape, just to make sure the segment never comes apart. That wouldn't be ideal. Also, if you're new to this live stream, these live streams, I am working on SN4's first test. Currently, I'm working on the propellant grain. This is what will fuel the next test fire. And I use a technique where I use multiple pours and build my way up, like if you're building a size skyscraper, building segments up by up and up and up and up and up. Now, so right there, I just added the segment, the second segment. This next SN4 is only gonna have 2 segments, and then there's gonna be a small segment to it. I'm just trying to cut off these two that I got off Amazon last time are not great. So I'm just trying to grab off some of it delaminates, but that's okay. Not the biggest deal. All right. If the stream freezes or anything, please let me know. Also, make sure you like the stream. If you have any comments, or if you just want to have a conversation, please text it below in chat. I'm going to put back on this top, and I'm going to set this over to the side. Now it is time to hot plates heating, preheating on low. Now it's time to come over here. Let's get the close camera. Now it's time to weigh out all of our chemicals. So we're going to first start off with sorbitol. We'll have the mixed jar. Now I have a sheet right next to me. So, also, can you guys hear me good? Does everything sound good? Okay, so we're gonna go with sorbitol first, so it's 52.5 grams of sorbitol. 52. Oh, that's over. Oh, 52.5. Perfect. Everything sounds good? Okay, great. Okay. Sorbitol is done. Now, once we do sorbitol, we're gonna put it in the mix jar. I try to get as much out as possible. Hit it. There we go. I mean, not 100% of it needs to be out, but just most of it. This is just like a little left. All right, so we got the mix jar. Now we're gonna grab potassium nitrate. This is what I was saying why um, labeling everything is smart, because now I could just reuse these multiple times. I don't gotta clean them between every time I pour propellant. Okay, so milled, we're gonna have 34.13. 30, 32, 30. Oh, right there. Oh, a little bit over. 1, 2. Oh, all right. I get my potassium nitrate, and I also do get my red iron oxide, my sulfur. I get a lot of my chemicals from Fireworks Cookbook. If you're located in the United States, I know they can ship to you. I'm not 100% sure how these chemicals will work. Oh, not that. I'm not trying to do that. I don't know how these chemicals work in a different country, but if you're in the United States, I would definitely check out Fireworks Cookbook. All right, now I'm gonna put the milled potassium nitrate in the bag so I can crush it down just to make sure there's no clumps, which there will be clumps. So this will help out remove all the clumps. All right. All right. Also, if I'm ever in a wrong camera view and you can't see what I'm doing, let me know. I'll switch the camera view. There's a fair bit of clumps in this batch. All right. All right. This looks pretty good. Cut it and put it in with the sorbitol. All right. Get it in right here. Also, future live streams, would you guys want background music? I'm not sure if that would be something that would add to this. All right, got the milled potassium nitrate. Now that can go in the back. We're going to grab the granular now. Yeah, let's tear it out. Granular, I got 63.38. All right, 62. Three point two, 38, 3.4, 39, 39, 38. All right, grab that. Next, put it in the mix jar with the rest. Cut that. That to the back. All right, one last thing, the red iron oxide, the most important. It needs to be the most precise. We got 1.87. Oh, right on the dot. That's nice. Boom. That in the back. Throw that in the mix. Definitely goes way faster. Like I was saying, that Finicil and the first pours take way longer than the other pours. Bring this up to the front. Switch over the station and everything to the pouring. I CNC all the, well, I don't, but I buy all my parts CNC'd. I do want to experiment in the future with 3D printed metals because the place where I get all my CNC parts also does 3D printing metals, which I think there's definitely some room for me to use that. Okay, we got okay, put it back. Yeah, this is just our candy, Rocky candy. Um, with I did modify it a little bit with some red iron oxide. I also do use I use two different mesh sizes of potassium nitrate, which I've seen worked great for me. Um, yeah, so I can read out what I got. Right now I do have overall I have a 65% potassium nitrate and 35% sorbitol. Um, this is how I display it. It might be a little, let me shake this while I'm just saying. So the potassium nitrate of the overall 65% of potassium nitrate, 35% of it is milled and then 65% of it's granular. And then and then by mass I add 1.25 red iron oxide. 1.25%. All right. It's looking good. We'll let that settle. Pot's heating up. All right. I have not tried a graphite nozzle. The only reason is because I don't have a lathe and no other place that I've ever reached out to said they would CNC graphite, which is understood because it's abrasive, it sticks to everything, it's a pain. Also, if you're watching it right now, if you'd like to like this, please do. Yeah, so the red iron oxide does change the burn rate. Change the rate slightly with 1.25%. It's not really changing it crazy overall, but it does a little bit. And I've seen that with the tests I've done, it has helped out. All right, so we got that heating. We'll give this another second to settle down before I open it up. All right, everything's looking great. So SN, let me just check something real quick. Yeah, so SN4 is going to have 9 inches of propellant. Um, that's how I measure it in. I do measure in weight and the length. When I am working on it right now, I'm measuring it with length because it needs to fit or it needs to fit inside of the casing. So yeah, SN1 had 6.5 inches of propellant, SN2 had 8.5 inches of propellant, SN3 had 10.5 inches of propellant. Then SN4 is going to be right in between SN2 and SN3 within propellant mass and size. So I'm gonna grab my because now that once I have these two sections casted, I'm gonna I'm gonna need to fine tune it. Because this is not 9 inches. Oh boy, we're glitched out again. Okay. And then each of these segments, let's see how each of these segments are around 4 inches. So I'm gonna need to add around, oh, it's glitched out again. Frozen again. All right, good. So yeah, each of these segments is around 4 inches. So we're gonna need to cut one of these. And we're glitched out again. I'm sorry, guys. This setup. Why did I start making rockets? I don't know. I really don't know. I just have always been interested in it. I've always been interested with space and, SpaceX and NASA and all that stuff. And then I don't know. I just thought I've always liked chemistry. I've always liked engineering, building stuff. So I really don't know. Just interested me. So started doing it. I enjoyed it. Made a YouTube channel to share it, share the things. I've always liked making videos. Made a YouTube channel to share our experiences. And yeah, it's just how it went, I guess. All right, we got the propellant poured in. Switch over to this camera or this camera. Which one? One or two? Camera one or camera two? All right, we'll shift this up to medium. There's some clumps in here that I'll get out. But overall, very uniform. All right, those clumps are out. I'll let this sit for a moment. While it heats up, and I will start mixing it. From how far am I standing? I'm standing around, I'd say, I don't know the exact number, but around 100 yards, maybe 150 yards. I'm also behind a mass just in case anything were to happen. But I am very far away, first of all, and then say by any chance if anything ever happened, even being around 150 yards away, um, I still have a shield in front of me. So yeah, that is very important. If you're testing any rocket motors, doesn't matter if it's you know cardboard, any type of material can damage. All right, so start mixing this around. Thermometer on hand. Go to the close view. So there's like three phases to this process right now. First starts off it's with powder, then it gets all clumpy. Once it gets clumpy, then it melts down into a nice liquid. I'm targeting 250 degrees. I usually take it off at around 245. And I pour it. I want to make sure everything's heated evenly. So I'm moving it around a lot. Start seeing some clumps. Give that a second. Well, I don't think I'd fly the rocket on commercial motors because I've done all this work making a motor, making it safe. I really do want to fly my motor. Also, I wouldn't be able to get my hands onto a motor with this power, I would say. Um, just being a beginner. I'm not, you know, I've been doing this for a couple of years now, but relatively new. And I like the fact that the motor's built by myself, the rocket built by myself, it's fully built by me. So also, but then, you know, it does. Yeah. All right, we're getting melted down pretty good. Gotta make sure all this doesn't touch the sides. Everything's like baking a cake, pretty much. Sort of. Very different, but alright. Once it turns liquid, I turn down the temperature to low. Yeah, no, it definitely wouldn't be too long to get certified. But I don't know. I'd rather fly my own motors. I think I've been working this hard building this motor and everything. I want to fly it. And if everything checks out, obviously if it's safe, I'm not gonna fly something on a rocket that could explode and then ruins my whole rocket and then it's not safe. So definitely it's also cheaper. If I can these rockets are a little expensive for the start with the CNC and casing stuff, but the reuse it only costs I don't know, not much, $10 in fuel to reload it and retest it and refly it. So if I could really get this, all right, I'm gonna turn down the low. If I can get this to work, SN4 is looking really well, and got pressure sensors now. I got more ways to collect data. So yeah, I just like the idea of building everything myself. Obviously, not everything. All right, we're getting pretty high up there with the heat. We're 216. targeting 250. Yeah, the rocket, like I wouldn't be making the nose cone or the avionics, the actual flight computer, but I do want to build the big overall parts, which one of the biggest parts is the motor, which is probably one of the most important parts of a rocket. And then the body I'll make, the fin can I'll make. Actually have a pretty cool idea for the fin can. I haven't seen too far. I haven't seen before. Okay, so we're at 240. I haven't seen this before, but I think it may work. I haven't seen it in high power rocketry, at least, I'll say. Um, but okay, so we're at the temperature. I am frozen once again. I don't know what's going on. Okay, all right, we're at the temperature. Get ready to pour. We're gonna just move this over to the right a little bit. Hopefully not miss. That looks good. All right, stop that. Swap it around. Pour some down the other side. Oh no. A little bit of it spilled out, but that's okay. That always happens. It's hard to get this stream of hot lava. Oh, that's hot. All right, we'll put the rest down this side. All right, this was a bit more sloppier than it usually goes, so we'll clean up. At least it's free. You can see some of it's coming down, but still very hot, so I don't want to touch anything. Grab. Put some clothes on. Can still throw these pieces down. So I got on the outside. Okay. Oh, nice little ball of propellant. Throw it back down there. All right. A little bit on this side. A little bit right here. Yeah, this is kind of a sloppy pour, but it's okay. Always turns out good at the end. Come on, get down there. All right, perfect. Now we're ready for the tamping. Get any air bubbles that may be in there out. Yeah. All right, everything's good. Turn off this burner. Take that back. Maybe they'll make their own lathes. I have not seen custom lathe, but yeah, it's definitely possible. Now we're gonna put on the cap, and we are frozen again. Oh no, at least my voice. Okay, got the cap on. I'm gonna start pounding this down. Let me know if it gets loud. I don't think the voice isolation is pretty good, but not getting it. All right, first tamp. Let it sit for a second. Okay, let's. Yeah, I mean, I could get a cheap lathe, but at the same time, I have very tight tolerances. Also, I'd be turning down stainless steel. I would, aluminum is much more softer metal, but I definitely want to get a lathe where I could turn down multiple different types of metal. So I don't need to get, say, I wouldn't just get a lathe that I can only turn down graphite and aluminum and more soft materials. I get a lathe where I can turn down anything. So then, um, do I have a three? I do not. I actually don't have a 3D printer. Um, it's pretty cheap. All the like, so I was saying in the other stream, I used to fly drones. All those were pretty. It's pretty cheap just to get stuff online. For the rocket, I'm definitely going to get a 3D printer for some parts of the rocket. All right, I'm going to grab a few of these pieces of propellant from the spatula and throw it down there. Don't want to waste any of this propellant. It's still tacky enough that it will get down there. Come on. Yeah. All right. I don't want to waste it. I need to it'll make less pores that I need to do. And these pores do get pretty tedious. Pretty tedious. I do probably two more after this. I might do one of them not on live. I'm probably gonna do one later today. I'm gonna do the final pour on. 'Cause then I do the final pour and the patch up um, around 3 days after the primary pours, which are these. All right, let's add down a little more. Let's see what temperature is it down here. Yeah, it's 150 degrees down here. Definitely want to tamp. I usually tamp till it gets to around 125 degrees because then once it's at 125, it's not really workable anymore. And whatever bubbles, if there is bubbles in there, they're not going to come out. Also, if you haven't liked the stream yet, please do. Appreciate that. How many likes do we have so far? 8 likes. That's good. Seven people currently on it. Let's see. Okay. Yeah. So yeah, I'll definitely look into those 3D printers. Thank you. All right. This is actually this is my I call it V2 casting materials because I'll show you this real quick. I had other stuff. This is my old casting materials. The Finicil also had five fins instead of three that it has now. The five fins were tough because there's so much friction in between all these to get it out. Also, I'm not sure you can see, but no, you really can't. This was resin printed and it's very rough. So it was very rough, so it's tough to get the rocket candy out from it. These new stuff, uh, the second casting hardware is different type of resin printed, and it works way better. Also, the V1 casting technique was multiple grains. So I would have 3 grains per one rocket. This just 1 grain goes into the rocket. All right, good. Everything's looking straight. Good, good, good. Yeah, later today I'm going to be working on the test stand. Um, currently upgrading the test stand for the new hardware for SN4's test, which I think we're targeting the end of the month, hopefully. Um, Dependent on snow, because I do live in a snowy climate. If it's actively snowing out, I'm gonna pass on testing, but obviously there's gonna be snow on the ground, I'll shovel. For SN three's last test, there was snow all around it. Now we got a lot of snow, so it's gonna be a lot of snow removal, but uh, yeah, it is also gonna be cold, so that is a good. Uh, it's gonna be harder to start up the motor in the cold, so that's why we're gonna be using the black powder to assist the startup. Um, in the summer, realistically, we probably won't need to use the black powder to help start up because the motor's gonna be way more warm. Um, Also, the motor is gonna burn differently in the summer because warmer, the faster it's gonna burn. But still testing in the winter will give me some good data from this rocket motor. I'm currently working on a system where I can control the climate within the test stand. It'd be pretty easy, pretty simple to do with the geometry of my test stand, but I'm not sure if I want to spend the money on it. But we're gonna see. It would be a pretty quick setup, probably take 1 or 2 days. So I still got time to think about that. All right, we'll tamp this down, get all those air bubbles out. Also, if you guys like these live streams and want more live streams for different things, I could do a live. I could do a live stream assembling and doing the test assembly for SN3. Probably, hopefully, the parts will probably be here by the end of the week. So if you guys would like to see that, please comment below, and I will 100%. I could 100% do that. Can't, yeah, I'm checking the website right now, and all the parts are almost done. They're all in quality control and packaging stage. One part's still getting milled down. But yeah, if you'd like to see that, get some sneak peeks from the videos, let me know. All right, this temperature is it? It's around 136, so I'm gonna tamp it down a little bit more. See how it's looking in there. Yeah, it's looking great in there, so okay. Okay. Clean up the station a little bit. Next casting, which I'll probably do later. I don't think I'm gonna live stream that because it is pretty repetitive from now on. I just keep on building up. I have two more pours to do, so it's just pretty repetitive. I'm guessing you guys probably don't want to see that. Um, so I will not. Get some videos here. On autofocus. All right, good videos like that. All right. Yeah, after this, I'm probably gonna finish up the script. SM4's videos, it's gonna be pretty long. comment below. How long videos do you guys like? Should I make? I don't know because I'm trying to figure out how much detail should I add because obviously the more detail I add, then the longer the video is. But I don't want to make the video too long or you get bored of it. But I'm trying to probably 15 minutes. Let me know your thoughts, but I'm targeting probably around 15-minute video. I think that would be good. I think it would be good. All right, we'll tamp down twice more. Okay. 15 minutes. Yeah, so that's probably what I was trying to. It's gonna be set up like any other video where I'm gonna have the intro, then I'm gonna be describing all the parts and then doing the testing and then doing the overview of the test and see how it is. I'm gonna add a segment on the upgrades. One second, I'll be back for 1 second. All right, I'm back. Yes, we're gonna do one more tamp. Then if you guys want to see anything, let me know before I go. Um, I have the test, and I could show you guys the test stand real quick. Um, it's pretty messy down here, but I can show you the test stand before I go. If there's anything else you want to see, please let me know. All right, tamp that down. All right. Yeah, I do use OpenRocket to simulate the rocket. Yeah, so I simulated the rough of the rocket. It's not too refined because I'm not 100% sure with all the parameters yet, but I roughly simulated it. The rocket says about, I think, 3,500 feet, just a terrible. Um, so right around 3,500 feet. Could possibly squeeze some more in there, but for the first rocket, I'm just gonna go for a successful launch over, a designated altitude to hit. Can you see the simulation? Um, yeah, I could show it. If I can find it. It's pretty crude right now. Um, let's see, rocket. Let's see. Oh, I think I disassembled it. Um, Yeah, so hmm, I think I can show you what I got. It's not nothing crazy because I've been messing around with this a little bit. Trying to figure out how big of a field I need to launch this so I can recover it because I don't want it landing in a tree. That'd be terrible. And around where I live, we don't have too many big areas of just flat land. It's not like I live near the desert or anything like that. That would be great if I did. It would be so easy to launch this. So let me get that file opened up. Now, how am I going to share it? Through OBS. Um, all right, I guess I will just share my screen again. Okay, so you guys can see everything. Please. Yeah, so this is it right now. Mind you, the motor that's in this right now is SN2. So this is SN2's motor in there, which SN2's motor is slightly underpowered and slightly heavier. So that's going to help out. I know I see the center of gravity and the center of pressure are very close to each other. I know they recommend um, whatever diameter your airframe is, which mine is 3, and we're not around 3 inches right now. Oh, sorry. Let me. You guys can only see like a quarter of the screen. Yeah, we'll do that right there. So yeah, so well, can you see it all good now? Let me know if you can see it. Um, so yeah, this center of pressure and center of gravity will spread apart when I get SN4's motor specs in there. So yeah, because that is SN2, which SN2 was slightly heavier and slightly less powerful. So we're at 4,200 feet right now, um, which seems, pretty realistic. Uh, Not anything's refined on this yet because there still is a lot that I'm working on. Um, so don't take any of this stuff. You're not seeing the final rocket at all. There's still a lot going on. Final rocket, final rocket will probably look pretty similar to this, um, but not quite. If you have any recommendations of what I should do, this is not a fully final simulation. That these masses are not totally correct. The parachute, I just have some default parachutes in there. I'm not 100% sure what parachute I'm using, so the weights aren't too accurate yet. Nothing's really accurate on this. This is just, building my ideal rocket. I mean, it has a whole different motor in there. It has SN2 in there. So, and SN2 is, like I was saying, won't SN4 be finished? I'm I'm just waiting for the parts to ship out. Once the parts ship out and get here, it'll take me probably, um, depending on the days, probably 3 days to test assemble, load it, and because I gotta first drill a few holes through the casing. I gotta first cut the casing, drill some holes through the casing, then do a test assembly. Once the test assembly is good, I will take it apart, put O-rings on, and then load it with the propellant. See, I'd say around 3 days. Um, Not of continuous work, but with how busy I'm right now, it'd probably take 2 to 3 days probably. Just depends on how busy I am. If I have how much homework I have. I don't have any exams this week. I had 4 exams last week, so this week I'm off of exams. So yeah, so that's why I'm hoping to test. I was really hoping for this coming weekend, but I don't think the part's going to be here in time. So The parts were originally supposed to get here on Wednesday, and Wednesday would give me Wednesday, Thursday, Friday, part of Wednesday, all Thursday, all Friday, and then test Saturday. That would be enough time. But yeah, the easiest way to increase stability, my nose weights. Yeah, so that's why I have this weight up here. I'm trying to, I'm not trying to, I want it to be very stable, but obviously the more weights I add, the less high it will go, the lower the apogee. But at the same time, I'd rather have a lower apogee and a stable rocket than a high apogee and a slightly not stable rocket. So I'm probably gonna, which also the this is why I'm not modifying it that much because the center of gravity and center of pressure, especially the center of gravity, is off because this is for SN2, and SN2 would weigh definitely SN2 weighs a lot more than SN4. So I'm keeping it at where it is right now. I'm hoping once I put SN4 in there, if I once I put SN4 in there and if the center of pressure and center of gravity spread apart, I'm hoping for at least 4 inches apart for stability. Then I won't change anything. If then maybe SN4 doesn't change it that much, then I'll possibly add weights. So increase the spin height. Yeah, what's the thing? Just put this over here. Yeah, it's slightly lowers the apogee, but yeah, this is a very crude model just to, get my feet wet in the beginning of the stages of development. Definitely feasible. Um, so yeah, that's where I'm at right now. I will show you guys. Let me tamp this down one more time. What temperature are we at? Probably pretty low, 100 degrees, 107. Um, I can show you guys the test stands if you want. I can show you my whole setup right now. Um, I'll take the camera down from the overhead mount because I do. Oh, maybe I can't. I have to try it out because I'm not 100% sure. Save this. I'm not 100% sure if I'm going to be able to get that. Okay, so all right, this is looking good. I'll take my phone down if you guys want to see anything. Yeah, the dual deploy is very. This is a very ambitious rocket for not really. I've launched the small rockets on like B and C motors, but for the first built rocket, most people have a black powder charge that comes off the motor to separate. But we're trying to dual deploy. If it doesn't work, if the rocket gets destroyed, this is not the end of the world. Honestly, arguably, it might be cooler if it gets destroyed, but I don't want that to happen. Um, but yeah, there'll be an onboard controller to set off the drogue and then the main chute. Drogue will deploy at apogee, and then the main chute will deploy um, lower. But the only thing is the real reason I really didn't want to do dual deploy, but the one reason I need to really is it's tough without not a lot of people launch at deserts and places that have a lot of land. I can't find that much land, so I need that drogue parachute so the rocket doesn't drift too far because if I don't have a drogue parachute and the main parachute deploys at apogee, it's very large, so it's going to allow the rocket to coast in the wind a lot. And I don't have a big plot of land, so that could risk it going in trees around the sides of the land. So that's why I kind of got to do dual deploy. I really don't have a choice. Because the last thing I want to do is lose this rocket on the top of the tree. Okay, so let me take this camera down. Still need the setup, but see oh, it does not look good. Maybe I can't. Um, let's see what we're looking at. If you can see it, oh boy, we got the yeah. See, there's something wrong with my camera. No, I haven't looked into those shoots. Over here we have the test stands. This is the main test stand. Over here I got poster board over the other test stand. That's for the flame trench. Because right now got all this poster board up for backing. Here's the other test stand. It's almost done. It's almost done with its renovations. But yeah, that's where I'm at right now. I think I'm gonna end off the stream here. Thank you for watching again. I'll probably go live in the future again. Well, I will go live in the future. Let me know if you'd like to see the test assembly of SN4 live. Yeah, and just let me know. All right, well, thank you for watching. Please subscribe, comment, like, and I will see you guys in the next video.